Today's the day when I show you basic operators in Python, the most common operators that you are going to use when you are coding. So we have three of them, three types of operators. I'm going to classify them using comments, all right, for us to follow a line of thinking that is going to be incremental, all right? So let's first create our file. So click with the right button of your mouse, new file, operators.py. Open the file and let's put the operators that exist. So as a comment, I'm gonna put here arithmetic operators, probably the ones you already know, comparison operators, and logical operators. I don't know if you say logic or logical operators. You can put in the comments, all right? So let's start with the arithmetic operators. You probably already know the basic ones like minus, like plus, minus, division with a slash, and multiply with a asterisk, all right? With an asterisk. Let's put some constants here. So sum 1 plus 1. So this operator here is the addition operator, all right? The operator that we use when we want to perform a sum, all right, of two values or more. Anyway, sum, subtraction, 1 minus 1, multiplication. Let's put mult here, 1 times 1, division, so div 1 divided by 1, right? These are the basic ones, but in Python we also have the exponentiation operator. So exp, not your exp, sorry, x to the power of, all right? Let's put another value here because 1 to the power of anything will not be a good example, but let's put 2 to the power of 2, right? You put basically 2 asterisks, right? So 1 asterisk represents multiplication, 2 asterisks represent exponentiation, okay? What else? Floor division, for example, floor div 2 divided, floor divided by 2, right? Basically the floor division is a division that rounds down the number, okay? So for example, let's put another number here to exemplify, like 2.5 floor divided by 2. We're gonna see that it is going to be rounded down, right? Because the result will have decimal parts and the floor division divides but takes off the decimal parts of the result, okay? So this is a perfect example of a floor division. And let me see the last one that we can check out now. Sum, subtraction, multiplication, division, exponentiation, floor division, and modulus, all right? This operation, mod, is basically when you want to discover a remainder of a division, all right? For example, 17 modulus, and the operator is the percent sign, the percentage sign. This is not percentage calculus, all right? This is not calculating the percentage of the value. Don't make this mistake, all right? This sign right here is mod, all right? So for example, 17 mod 5, the result of this operation is going to be 2 because like 5 goes 3 times into 17, all right? And what is the remainder? 2, you know? So that's how this operation, this operator works. Don't forget this, and don't think wrongly that the percentage sign is basically a percentage operation. Okay, you calculate percentages in other way that you're going to see in the future. Okay, so these are the basic arithmetic operators. Let's print to see the results. All right, so print sum. Let's see what sum looks like with the addition operator. Probably you already made some operations like this. So Python operators .py 1 plus 1 equals 2. Perfect. Let's print now the subtraction. 1 minus 1 is 0. All right, no problem with that. Another one is the multiplication. So 1 times 1, probably 1. All right, you can see here 1. Let's change the values for us to see another examples. So 129 times 232. Let's see this result. It's 29,928. Okay. Let's put another one here. So 10 divided by 3. Let's see the result. Sorry, I forgot to print the division result. Forgot to change here the parameter. Now we have 3 point many decimal parts of 3 and the last one being 5. Okay, so this is a float number. That is the result of the division, 10 divided by 3. All right, let's see the exponentiation. So 2 to the power of 2 is 4. All right, let's put another one here. 2 to the power of 4 is 16. All right, exponentiation. Floor division, a good example for us to see now is the same one that we have here, 10 divided by 3. We can use as an example as 10 floor divided by 3, and let's perform this operation. Let's see what happens. And wasn't that supposed to show 3 point many decimal parts of 3? Many numbers repeated 3 as the division shows us? Not really, because this is a floor division. It takes off the decimal parts. All right, and to finish, let's see the modulos. 17 mod 5 is 2. So basically, how many times 5 goes into 17? 3, but 2 is the remainder, right? The rest is 2. How can we discover this? How can we discover the remainder? How can we discover the remainder of a division using the mod operation? Okay, that's how you perform operations with the arithmetic operators. These are the arithmetic operators in Python. Let's move on now to our comparison operators. All right, we're going to use this as a programmer for your whole life. The arithmetic operators you are also going to use, but honestly, the comparison operators goes more like to the programming logic techniques that you are going to apply. All right, so the comparison operators basically are operators that we use to compare things. Okay, so for example, if something is equals to other thing, for For example, 1 equals 1. Let me print this for you to see what happens. You can see that we got the return true because it's true. 1 is equals 1. Is 1 equals 1? Yes, true. We get a Boolean return based on the question that we made to Python, all right? So every time you see something like this, let's get this out of here. Every time you see something like this, this is a comparison operation, and this is going to return a Boolean data, all right? So this is a comparison, returns bool. Okay, for you to remember that this is a question. Everything that returns a Boolean can be read as a question, right? So is 1 equals 1? Let's store and print. We're going to see that the result is true. The good thing here is that you already know that 1 equal sign represents assigning, represents that you are putting a value inside of a variable or a constant in this case. Okay, so the equals to operator, comparison operator, you must put the equals twice. All right, this is the trick here. 1 equal sign represents assigning a data to a variable. 2 equal signs represents a comparison operator that is comparing two values to see if they are equal. All right, so for example, if I put like this, you are going to see that if I print, I'm going to have the return false. Why is that? Because even visually this appears the same, even if it visually the value appears the same, it's not, because we know that this is a integer, this is an integer, and this is a string. All right, it's between double quotes, so even if it is a number, we know that this is a string, is a text. All right, so one number is equals to one text. No, they are not the same, because they may appear the same, but they are from different data types. So how can they be the same? So Python is going to return false. All right, so this is the equals operator. Another comparison that we can do is greater than. Greater. All right, so is 1 greater than 2? If we print the result here, you're going to see that 1 is not greater than 2. It's false. All right, how about 3? Is 3 greater than 2? If we print, we are going to see that it is. All right, that's true. Okay, the same thing we can do with the less comparison operator. So is 3 less than 2? No, sorry, I forgot to print the less. Now false. 3 is not less than 2, right? So in the less than comparison, we get the false result. Is 1 less than 2? It's true. 1 is less than 2. Okay, these three operators here are the basic comparison operators, but we can mix them. So we can check if, for example, greater or equals than. So for example, is 1 greater or equals 1? Let's see. So greater or equals, it is going to return true. If we try like is 1 greater than 1, we are going to have the result false, right? Because 1 is not greater than 1. But why in this case greater or equals returned true? Because one of the conditions were satisfied, all right? Just one of them. If one of the conditions is satisfied, we have the result being true, right? So 1 is not greater than 1, but 1 is equals 1, equals to 1, all right? So in this case, we have the return true, all right? Same thing for less or equals than, all right? Less than or equals to in this case. So less or equals. So is 1 less than or equals to 1? What you think is going to happen now? We're going to have the true result. But 1 is not less than 1. No, but it is equals. So one of the conditions were satisfied. Okay, and the return is true. Okay. So these are the basic comparison operators, but we have another one that is the different, right? So the same way we have here the equals being 2 signs of equal, 2 equal signs, we can put here the opposite, like different. And the different is basically exclamation point equals. This guy right here represents difference. So this question is 1 different than 1? If we print the result, we are going to see that is not. 1 is equals 1. 1 is not different than 1. But if we do is 1 different than 2, we are going to have the result being true, because it is. 1 is different than 2. Okay, so this is the other comparison operator that I forgot to tell you in the beginning. Instead of telling you with the unique comparison operators that are these, I taught you after teaching you the composed comparison operators, all right? But there's no problem. These are the comparison operators in Python. Now let's finish our lesson with the logical operators, right? The logical operators are AND, OR, and NOT. All right, let's start with the AND logical operator. This logical operator allows us to evaluate if 2 or more conditions are true, all right? If they are, the result, the final result is true. So it evaluates individually, gets the output result of each condition, and if all of them are true, it returns true. If one of them is false, if one of them is not true, it returns false. Alright, so like this logical operator is a strict comparison between Boolean outputs. For this evaluation return true, every result of every comparison must be true. Alright, let's put in practice. So let's evaluate if someone can join our programming contest. Alright, so the first thing we are going to evaluate if the person is a programmer. Alright, if the person is not a programmer, the person cannot join. So profession, programmer. The second thing that we have to evaluate is if the person paid the tax to join our context. So payment status equals true. Right? So the profession is programmer and the payment status is true. So when we compare profession, let's put here can enter receives profession equals programmer. If we print can enter, we are going to see that yes, it can, right? The person can enter because it's a programmer. But you can see here that we didn't evaluate the payment status. How can we do this? Using the AND operator. Alright, so AND payment status equals true, right? Let's see, can enter. But let's change this. The person didn't is a programmer but didn't pay. False. You see, one of the conditions is true, but the other one is not. And this could be the opposite. The person can have paid the tax, but it's like a politician. He's not a programmer, he's a politician. Let's see if this person can enter. No, it can't. The person can't enter because although the payment was made, the profession is not the profession that we have put as a filter to participate in our programming contest, in our hypothetical programming contest. All right, so this is how the AND logical operator works. And let me use this situation to show you that when you are evaluating a Boolean data, you don't need to make it explicit like this. All right, you cannot, you don't need to put like payment status equals true. No, you can just put payment status. All right, if you put a Boolean variable in a comparison, Python already interprets for you as is that true. All right, so if I put AND payment status, it's the same thing of this, but with no need to write. All All right, so let me get this out. So that's how the AND logical operator works. For something to be true, all conditions must be true. If one of them is not true, the final result is false, right? You could have like 10 conditions here. If 9 conditions are true but one is false, the result would be false, all right? The return of this logical operation would be false. And with that said, you can imagine that the OR logical operator is a little more flexible, all right? Because the OR logical operator returns true even if not every condition, not every comparison returns true. If just one of the conditions are true, that's okay. The person can enter, all right? So in this case, if I run now, we're going to see that it's going to return true, right? Because what's the profession for someone to participate of our contest? The profession is programmer. Is this person a programmer? No, this person is a politician. But we have other condition, that is, or payment status true, all right? So if the person is not a programmer, but the person paid, the person can enter. So is this case, this politician paid, so he can enter, no problem. The opposite is also true. So programmer, but didn't pay. When we use the OR, this programmer that didn't pay is going to participate because he's a programmer. It doesn't matter if he didn't pay, all right? Because one of the conditions is true. So we could have 10 conditions. If 9 are false but one is true, because of that one, it returns true. And in this situation that we are exercising right now, this hypothetical programming contest, the person can enter if it's not a programmer but paid, if is a programmer but didn't pay, right? And we only use 2 conditions here, 2 parameters here to compare, but we could use many ones. So if we had 10 conditions, we could compare the 10 conditions. But remember, if you are using the OR logical operator to compare, if every condition is false but one is true, it returns true. If you are using the AND logical operator, if every condition is true except for one condition, it returns false, right? This is like how you think about the logical operators and OR. So that's how logical operators work, and in general, that's how operators work in Python. We have arithmetic operators, we have comparison operators, and we have the logical operators. If you know how they work, you are going to be able to express powerful logic code, all right? Powerful logical code. These 3 types of operators combined are going to give you power to write powerful code, all right? Because with arithmetic operators, logical operators, and comparison operators, you can write logic that thinks, all right? Of course, not deeply as an artificial intelligence will think, but huge comparisons and huge analysis, huge decision making, huge answers you can discover with these 3 kinds of operators. All right, so that's it for today. These are some of the real interviews that I recorded to show you how real companies interview developers from inside. Use them to prepare for real interviews and get the job of your dreams. Go to marosacademy.com or click the link below.